Continuous Integration and Delivery, or as you may have heard it called, CI/CD. My name is Andy Thielking, and welcome to my DevOps course on setting up a CI/CD pipeline. In this course, we will cover a variety of different CI/CD pipeline products, as well as how to create and deploy a CI/CD pipeline using some of the most popular solutions. A general understanding of DevOps concepts in CI/CD is recommended, as the theory of DevOps and CI/CD won't be covered in depth, but more a practical application of those concepts. Now, let's get started. In this course, we will cover source control repositories and how they play a key part in the CI/CD workflow. We'll also explore hosted solutions for CI/CD platforms such as GitHub, Azure DevOps, and GitLab. We'll then work on creating and deploying a CI/CD pipeline to one of these hosted solutions. And finally, we'll learn how to inspect the results of a pipeline and interpret the output. First, let's imagine a scenario. You are the Wired Brain Coffee Company's first internal software developer and DevOps engineer. You've inherited a software system built by an outside contractor, which you will be responsible for maintaining and upgrading. Previous developer didn't find the need to set up a robust CI/CD pipeline and follow modern DevOps practices. They at least had a version control system set up. However, building the source code, testing the system, and finally deploying the system to the cloud all happened locally from that developer's machine. None of this you have access to now. So what do? Let's dive in and start exploring what makes up a CI/CD platform and how we can remedy the situation by setting up our own CI/CD pipeline. So what exactly does CI/CD mean? Well, CI stands for continuous integration, which is an automated process of building and testing each change within a software system. Basically, whenever any developer checks in a change, the CI system automatically begins building that specific version of the code to ensure that particular change doesn't prevent the software from building. Automated tests are then usually ran after the build step to ensure that the change didn't break anything behaviorally within the software. CD stands for continuous delivery, which just means that software can be automatically deployed to any environment at any time. This will happen after the continuous integration step, because the CI step acts as a validation by ensuring that changes that are being made won't affect the system adversely if those changes are deployed. We kind of touched on it in our scenario, but let's also describe what the core components of a CI/CD platform are. First, we're going to need a source control repository to store our code and keep track of changes. Next, we need a system which can automatically build our code each time a change is introduced. Third, we need a way to test each version of the code to ensure that each individual change doesn't introduce a bug. And lastly, we need a system to deploy any version of our code to any environment that we have. These last three steps of build, test, and deploy can be grouped together and thought of as a singular unit called a deployment pipeline. Now that we know the components of a CI/CD platform, we can see what a basic workflow might look like. You, as a developer, will check in some code to the source control repository. The CI/CD platform will detect the change and kick off the deployment pipeline, starting with building the code. Once the code is built, the automated tests will be run, and then finally, the code will be deployed to some environment. This is all happening on a server or machine separate from the development machine you work on every day. This helps to ensure that there isn't anything specific to your machine which will enable the software to be built and deployed. This helps with portability as well as onboarding new team members quickly. So using a CI/CD platform seems like a good idea, right? Like anything else in the technology world, there are many options to choose from. And I won't be highlighting all of the options here, but these are 4 popular options that many software teams use. GitHub is probably the most popular platform for hosting and sharing code. They also have a robust CI/CD tooling platform called GitHub Actions, which enable the deployment pipeline we talked about earlier. Azure DevOps is another popular product, which was Microsoft's offering and competitor to GitHub until Microsoft acquired GitHub in 2018. Now they both exist separately. However, you will see many similarities between the two, as well as the ability to easily integrate between them. GitLab and Jenkins are both open source alternatives to the closed source GitHub and Azure DevOps offerings. They both have the option to self-host the platform on your own infrastructure. GitLab is somewhat unique as they also offer a managed service as well as the option of self-hosting. Now that we understand what makes a good CI/CD workflow, as well as what platform options are available to us, we're going to start building our CI/CD pipeline by setting up a GitHub repository. This is the code base you have inherited from the third-party contractor for the WiredBrain API. For demonstration purposes, I've kept the code very simple because we won't be focusing that much on the code itself, but rather setting up the tooling around the code. Like we said earlier, the contractor had Git already set up for this project. And you can see by pulling up our terminal and running a few Git commands, there is some history in the project. However, you want to migrate this to GitHub. So let's head over to github.com and create a repository. This is the new repository page on github.com. All we have to do is set the name of our repository, WiredBrain API, and click Create. If we look here at the bottom of the page, we can see that GitHub provides us with some commands for either setting up a new repository or working with an existing repository. Since we already have a repository set up, we'll be focusing on these commands at the bottom. Now, we can pull up the terminal again, and first we'll execute a command to set GitHub as the remote repository. Once that's done, we'll execute another command to push all of our code up to GitHub. And now we can refresh the page and see that all of our code has successfully been pushed up to GitHub and our repository has been set up correctly. Now that we've successfully set up our GitHub repository, it's time to begin creating our deployment pipeline, and we'll be using GitHub Actions as our CI/CD platform. In this module, we'll walk through all of the key components of a GitHub Actions configuration file, as well as configure our own GitHub action for the WiredBrain API. Referencing our CI/CD workflow diagram from earlier, we just finished setting up our source control repository on GitHub. And, as you remember, the first step in the deployment pipeline is the build step. Let's begin configuring this step by taking a look at the structure of a GitHub Actions file. This is a basic skeleton of our GitHub Action workflow file. This is a YAML configuration file with some key blocks which control how the platform executes our deployment pipeline. First, we have a name block where you can set a human-readable name for the action. This will appear on the GitHub UI where all of your actions will be listed, so it is important to pick something meaningful. Next, we have the on block, which controls how and when this workflow is run. I've defined two triggers in the on block to start us off for right now. The first is a push trigger, which is just saying this workflow should run whenever new changes are pushed to this repository. However, having this workflow run anytime a change is pushed to any branch wouldn't be practical, as we want other developers on our team to be able to push changes to their feature branches without triggering a bunch of workflow runs. So we can filter that trigger down by specifying we only want this to run when changes are introduced to the main branch. The second trigger we've added is what's called a workflow dispatch trigger, which is just the GitHub action way of allowing this workflow to be triggered manually from the UI. Next, we have the jobs configuration block. There isn't much to this block, as the real meat of the workflow happens in the steps specified within the job. One thing to note is the runs on block, which allows you to specify the type of virtual machine to run this job on. Depending on the type of project you are working on, you can specify a Linux, Mac, or Windows type machine. Since our demo project uses .NET 8, which is cross-platform, we'll just specify Ubuntu latest and use a Linux machine. Lastly, the steps block is where we actually begin issuing our commands to build our project. This would be something like transpiling a Node.js TypeScript project into JavaScript, or installing pip dependencies for a Python project, or, in our demo's case, running .NET CLI commands to restore and build our C# project. It's time to put this into practice by heading back into our editor and work on creating the GitHub Actions YAML file and configuring the build job to build our code. The first thing we are going to do is create a couple of new folders in our project. GitHub Actions automatically looks for YAML files inside of a workflows folder, which is nested inside of a top-level .github folder at the root of the project. So let's go and create those now. First, we'll create the .github folder, and then we'll create a workflows folder underneath it. And finally, we'll add a YAML file called cicd.yaml which will be our deployment pipeline configuration. And I'm going to paste in the configuration we described earlier. The only differences being I've actually filled out the steps for this pipeline. Let's quickly recap this file. First, this will show up on the GitHub UI as wired brain workflow, since that is what we specified as the name property. Next, we defined our two triggers, the workflow dispatch trigger, which allows us to manually trigger the workflow, as well as the push trigger, which will automatically run this workflow when changes are pushed to the specified branches, main being the branch in our case. Then we have the jobs configuration, and we are specifying a build job which runs on a Linux virtual machine using the latest version of Ubuntu. Now we are at the actual steps of the build, which are the commands to actually build our code. The first step is a checkout step. You'll notice it looks a little different as it has this uses property. This property is specifying a pre-built action provided by GitHub, which allows you to do many common tasks without having to write everything yourself. In our case here, we're using the checkout action to check out the repository onto the virtual machine running this job before starting the other steps. The next step in the process, again, uses a pre-built action from GitHub. This action is ensuring the .NET SDKs and tooling are installed on the virtual machine running the job. This one is specific to .NET. However, there are pre-built actions to set up the environment for other common development scenarios, such as Node or Python. The next two steps don't use a pre-built action, and we are just manually specifying the commands to run using the run property. Think of this as your terminal window, where you can put commands and scripts to execute within the virtual machine. The type of shell will vary based on what type of virtual machine you specified in the runs on block. Since ours is Linux, this will execute as a bash command. The first of these two steps is running a .NET command, which will restore dependencies. Again, if you aren't from the .NET world, this could be something like npm or pip install instead. And the final step we have here is running .NET build, which will actually do the compilation of the C# code. Now, let's commit these changes and push them up to the Git repository, and head over to github.com to see what's happening. If we click on the Actions tab, here are all of the actions for this repository, wired brain workflow being the only one so far, and matching exactly what was specified in the name property. We can also see that our pipeline was triggered automatically by the push to the main branch. Additionally, each step in the job produces output to the console. So if we navigate to the build step, we can see the message that the .NET build was successful. Now that we've successfully set up the build step in our CI/CD deployment pipeline, the next step is to add some unit tests to our code and add the testing stage of our pipeline, which will begin to automatically run our unit tests each time the pipeline triggers. This will ensure that we don't deploy any broken code to any environment. So this is what our pipeline should begin to look like as we start to add more functionality to it. I've purposely omitted some of this file so we can focus more on the steps of the pipeline rather than the more boilerplate configuration we covered earlier. The first thing to notice is specifying the ID property of the build step. This is important to specify if you ever want to look back at a previous step in the pipeline and utilize a conditional statement based on the outcome of the previous step. And moving down to the test step, we can see where we specify this conditional by utilizing the if block. We are referencing back to the build step and telling the pipeline only to run if the build step succeeds, meaning the test won't run if the code doesn't compile. Let's jump back over to our development environment and begin updating our ci/cd.yaml file to include running our unit tests automatically. So I've already added a unit test project to our sample code, which gives us a couple of basic tests to run within the pipeline. Again, I don't want to focus too much on the specific implementation of the code or tests here, because we are really just using this as a way to illustrate how to run tests within a CI/CD pipeline. I'm now going to paste two more steps into our pipeline. The first step is the actual testing step, which runs the .NET test command to run our unit tests within the pipeline. I've provided some additional arguments here to collect code coverage data which we will use in the next step. The second step is a step which produces a code coverage report by ingesting the XML file from the first testing step. We'll see the familiar uses keyword here and recognize that this is a pre-built action. However, this action is different than the pre-built template actions from earlier. This one is not provided by GitHub itself, but rather this is a third-party open source action provided by the community and submitted to the GitHub Actions marketplace. You can find many useful template actions for things such as producing a coverage report. In this action, we provide a few parameters to how we want this to behave within our pipeline. This would also be the place in your pipeline where, if you wanted to ensure your code maintained a certain level of test coverage, you could enforce it here. In this specific case, we'll say we don't want to enforce a minimum threshold because, for demonstration purposes, we don't have that many tests set up. Now, let's commit these changes and push them up to GitHub. If we navigate back over to github.com under the Actions tab, we can see our push to the main branch automatically triggered our pipeline. Now, if we wait just a second for the pipeline to finish running, we can then navigate into the pipeline run and see our 2 new testing steps have been added. Furthermore, we can expand each of our testing steps and inspect the results. Our .NET test command notifies us that our 2 tests have passed and output our code coverage file to the following directory. And our code coverage report ingests the XML file and lets us know our coverage percentages. As an aside, just like any other virtual machine, the machine which is running the pipeline has its own internal file system. Each step within a job runs on the same machine, so files can be shared across steps using the file system, just like we have done between the test step and the code coverage step. Each new job, however, runs on a new machine, so anything left after the job finishes will be cleaned up and not available to the next job. There are ways to share things between jobs, but we'll cover that more in depth in the next module. All right, now that we have building and testing set up in the pipeline, we can ensure our code is ready to be deployed at any point in time. Now, as a caveat, the unit tests we set up here were pretty rudimentary, and in a real-life production scenario, you may want to add additional steps for not only unit testing, but potentially integration testing as well. Each team is unique, and the testing strategy, along with the amount of risk you are willing to take, are all considerations you need to make when building your CI/CD pipeline. So for now, let's assume the WiredBrain team is happy with our testing strategy, and we can move on to building the deploy portion of our CI/CD pipeline to enable continuous delivery of the WiredBrain API. First, remember that the CI/CD pipeline can contain multiple jobs, and we've only been configuring one job for building and testing so far. We'll now configure a second job for deploying the code to our environments. Next, we need to add one more step to the build job to preserve the artifacts from the build phase. This allows us to retain the exact version of this code. In case we ever need to roll back, we can do so without having to rerun the entire build job, and can rather just reuse the artifact in another run of the deploy stage. This is also how we're going to share between the build job and the deploy job, as I briefly touched on at the end of the last demo. And lastly, we'll actually configure the deployment job steps to push our tested code out to the cloud. It's time to add the final phase of our CI/CD pipeline. In this demo, we'll add steps to our build job to retain our build artifact, and then we'll configure a new job to handle deploying our code to the cloud. First thing we're going to do is finish out the build job by adding 3 new steps for publishing the build artifact, and I'm going to paste them in now. The first step, again, is more of a .NET specific thing, which is running the .NET publish command. This command bundles the compiled application and its dependencies into an output directory, which is then ready to be deployed to a host system. The second step is simply creating a zip archive of this publish directory. And the last step is retaining the zip file as our build artifact. Think of your build artifact as the output of this entire build phase of the CI/CD pipeline. Your build phase takes in the source code and outputs this artifact, which has been tested and we know is working appropriately. From there, we can save this artifact as part of the pipeline run. and then it will be retained for a certain number of days in case we ever want to roll back to this version. Additionally, if you have multiple environments set up, you can move this exact specific change set through each environment, say development, QA, and then finally production. And you will know that nothing has changed between those environments because it's using this exact same build output for each environment. Let's go ahead and commit these changes to the build pipeline and then head back over to GitHub to check out the results of the pipeline run. All right, I'm here on GitHub again, and I'm inside of the specific pipeline run, which we just triggered by pushing those changes. You can see it has the 3 new steps we added of publish, which runs the .NET publish command, zip artifact, which compresses the publish folder with the zip command, and finally, the upload artifact step, which uploads the zip file to the pipeline, and all of them successfully completed. If we head back one page into the summary for this specific pipeline run, we can see where the artifact gets retained and is now a part of this pipeline instance. GitHub even gives you the option to download your artifact to your local machine, which can be helpful if for some reason a specific version isn't working in your deployed setting and you need to investigate if all the dependencies are being bundled correctly or do some sort of other troubleshooting. We're now back in our CI/CD pipeline file, and it's time to configure the deploy job, which will take the build artifact and deploy it to the cloud. I'm going to paste in the configuration for the deploy job, and we'll walk through the steps, just like we did the build job, to see what it's doing. The first thing to note is we added an additional configuration setting to the deploy job itself. It is this needs block. This configuration setting is building a dependency on the build job, similar to how we use the if conditional in the steps of the build job. The needs block is saying the deployment job can only run if all of the dependent jobs, build in our case, complete successfully. Now our first step within the deploy job is to download the build artifact published in the last step of the build job. Since these are 2 separate jobs running on 2 potentially separate host machines, we cannot use the file system to share information. So we need to download it from the pipeline instance itself in order to get the files we need to deploy. The second step is going to vary based on your own needs. For this demonstration, I've chosen to deploy our code to Microsoft Azure. So in order to do that, we have to authenticate ourselves with our cloud provider. This step is utilizing a pre-built action provided by Microsoft, as you can see with the Azure login uses configuration, which allows the machine running these deploy commands to actually make changes within our cloud environment. There are a few things we need to touch on within this step, as it is introducing 2 new concepts. The first one is one of the arguments passed into the template action is this creds argument, which is using a different type of syntax than we've seen yet in this pipeline. This is the GitHub expression syntax, and it lets us reference different contexts within GitHub as objects rather than as a string. And in this case, we are referencing the secrets context to provide the credentials to execute the Azure login command. The next thing is the use of these different types of contexts. GitHub provides a handful of different contexts which all serve different purposes. However, in this instance, we are referencing a secret using the secrets context. Secrets in GitHub are a way to store sensitive data such as login credentials in a secure manner. This solves the problem of your pipeline needing sensitive credentials in order to do a deployment while avoiding checking insensitive information into the repository. Secrets need to be set up manually ahead of time, where they are encrypted and stored within each repository. The secrets are then loaded into the pipeline context as it is running and can be referenced and used just like any other variable within the template. They are essentially environment variables for the virtual machine which is running your pipeline. And lastly, once we have authenticated to Microsoft Azure with the pipeline, we can then do our actual web app deploy using another Microsoft-provided action to deploy our artifact to our cloud infrastructure. All we need to provide it with is the name of the resource we are targeting in Azure, as well as the file we want to upload to it. I also just want to reiterate that the deployment phase is going to vary greatly based on many factors, such as the language ecosystem you are building on, the cloud provider you are using, and even the different types of services you are using within each cloud provider. This demo featured technology from the .NET ecosystem and the Azure cloud. So if you're building a Node app on AWS or a Python app on Google Cloud,
You won't be able to utilize the exact same steps we are using here, but you should be able to follow the general principles and apply them to your specific application's needs. Let's now commit and push these latest changes and head back over to GitHub to take a look at the deployment job. We can now see that our action has these two boxes rather than just one, each representing the different job we configured. Since we also configured a dependency between the build and deploy jobs, GitHub has this nice visual hint that these two jobs are linked. Let's navigate into the deploy job so we can inspect what happened during the deployment. We can see the 3 steps we configured, the first one being the artifact download, which is downloading the zip file retained in the pipeline run to this new host machine running the deploy job. Next, we can see the Azure login step. This one is interesting because, as you can remember, it is using our secret in order to authenticate to Azure. So this step retrieved our secret from the repository secrets, used it with the Azure login action, and successfully authenticated to Azure, all without exposing our private login information anywhere. And lastly, we can see our successful web app deploy to the Azure App Service, which pushes our build artifact, a zipped up .NET web application, up to the Azure App Service where it is now running in our cloud environment. Let's take a second to recap everything we've accomplished. First, we established that the Wired Brain API was going to use GitHub and GitHub Actions as its CI/CD platform. From there, we began configuring our deployment pipeline, which encapsulates the build, test, and deploy steps of the CI/CD workflow. This is all done using a single YAML configuration file within our project. Now, whenever a change is checked into the source control system, our deployment pipeline will automatically verify the change can be built, there are no breaking tests, and additionally, we could enforce a certain level of test coverage. After all of that passes, our change is then automatically deployed to our cloud environment. This is a much more robust system than the Wired Brain team had before. In this module, we'll use everything we just learned with the CI/CD workflow on GitHub to compare and contrast the features of some of the other popular CI/CD platforms. You may remember this diagram from earlier. We briefly touched on 4 popular CI/CD platforms: GitHub, Azure DevOps, GitLab, and Jenkins. They each take a unique approach to CI/CD, and while Jenkins is a fine option for many teams, this module will be focused on comparing the cloud-hosted options offered by GitHub, Azure DevOps, and GitLab. All 3 of these platforms have the ability to build, test, and deploy your code wherever it needs to go. There's no one best option. There are differences between them, which we will highlight as we go through this module, but at the end of the day, you can accomplish your CI/CD goals with any one of them. GitHub Actions and Azure DevOps pipelines are quite similar in their approach to file configuration. They both have triggers for when to run the pipeline, jobs that are configured to run on different types of machines, and steps within each job to execute a specific action. The biggest difference between the two of them is Azure DevOps adds an additional layer of objects within each pipeline called stages. With GitHub Actions, the overall unit is called a workflow, which contains one or more jobs, and each job contains one or more steps. Azure DevOps, on the other hand, the overall unit is called a pipeline. Each pipeline has one or more stages, each stage contains one or more jobs, and each job contains one or more steps. Another slight difference is the idea between actions in GitHub and tasks within Azure DevOps. An action and a task at its core are the same thing, which is a pre-built, reusable unit of work for that step of the CI/CD pipeline. You can see that illustrated here with the setup.NET step. But the platforms just slightly differ on this concept with some naming and syntactical differences. Alright, so let's now look at a demo of the Azure DevOps platform and check out some of its features. I'm inside of Azure DevOps and on the Wired Brain project. One of the big differences between GitHub and Azure DevOps as a whole is Azure DevOps is designed more as an enterprise software delivery platform, where there is this concept of projects where different teams can organize their work. Each project contains different features within it. Boards, which are a work tracking, Kanban, and Scrum tool. Repos, which are Git and TFS repositories to store your code. Pipelines, which are the CI/CD pipelines we'll be looking at. Test plans are an area for QA to manage testing, and artifacts are a private dependency feed tool. While we won't be covering all of these in depth, it is good to know that they exist and act as a differentiator between the platforms. So we are in an instance of a pipeline execution for the WiredBrain API, and we can see a familiar type of user interface. Our two stages, build and deploy, are dependent on each other, so they show that they are linked. If we go into the pipeline details, we can again see a similar list of steps and the output to the console from each of the steps. Something I'd like to highlight is on the testing step of our pipeline, where we collect code coverage results from our tests. In GitHub, we used a third-party community plugin to view our code coverage data. On Azure DevOps, we use a similar task to publish the code coverage results, except the task here is provided by Azure DevOps itself. And if we go back one page to the pipeline summary, we can see there is this coverage tab toward the top of the page. Clicking on it brings us into the code coverage results we published within the pipeline. But instead of just code coverage data summarized in the console, we are presented with our coverage data in a nice HTML-style UI. Next up, let's compare GitLab to our familiar GitHub workflow. GitLab has a similar structure to Azure DevOps, with stages, jobs, and steps. The order of the items in this stages configuration is what defines the execution order for the jobs. Jobs within each stage can be configured to run in parallel, or after certain dependent jobs finish by constructing dependencies between the jobs, just like we've seen before. One of the more interesting things about GitLab is the ability to actually specify the specific Docker image you want to use for each job. Both GitHub and Azure DevOps have pre-configured build agents provided by Microsoft. Here, with GitLab, you can specify the exact image you want, as you can see illustrated by the image setting. In this case, we're using a Microsoft Docker image, which already has the .NET SDK pre-installed on it. This allows us to skip the setup.NET script we had to do with GitHub and Azure DevOps, and allows us to just jump right into our .NET build commands. Let's take a look again at the UI for GitLab and see how it compares to the other two platforms. GitLab, similar to Azure DevOps, has the concept of a project where work is contained within. GitLab also provides repositories for storing code, but like GitHub, lacks the project management sort of tools that Azure DevOps provides. Not really anything that impacts our CI/CD workflow, but just something to note. If we move over to our pipeline executions, we can see a similar UI we are familiar with from the others, a list of executions and the status of all the stages within that execution. If we go into a specific execution, we can see the different stages. And clicking on the Jobs tab lists out each job so we can investigate the output. Let's investigate the testing job so we can see how that looks compared to the other platforms. I'll also mention that GitLab, similar to Azure DevOps, has built-in coverage reporting as well. Publishing the coverage results as a pipeline artifact gives the platform the ability to show code coverage metrics as part of the pull request process. We've really only scratched the surface of the capabilities of these three powerful CI/CD platforms. And in the case of our example, we were able to use all three of the platforms to accomplish our goal. Sure, the files may look different, but they all essentially function the same. If you're interested in doing more or using one of these platforms for your own projects, I'd encourage you to check out the official documentation where they explain in much greater detail what these platforms are capable of. Thank you for taking the time to watch my course on continuous integration and delivery. I hope now that as we wrap up this course, you have a better understanding of what a CI/CD platform does, as well as how to get started building a CI/CD pipeline for your own project or company.